Okay, welcome back. What I want to do is continue with the electrotechnical technology level 3. Okay, now as I said before, it's a 4-year course to train to be an electrician, so it's not going to happen in 5 minutes, and some of the lessons overlap. So we have unit 1, outcome 6, session 7. Okay, and if you look before, you would see that I did outcome 6, session 6 previously. Okay, so it does follow on. So what I want to look at today is going to be types of three-phase induction motors. Okay, again, health and safety is always applied in every instance. Okay, it is never ignored, and you'll find that you would have done health and safety in unit 301 or 201 or even 101 in the new possible systems. Okay, understand the functions of electrical machines. Okay, and that's what we're going to be looking at for today. The student will be able to identify three-phase induction motors and distinguish between a cage rotor and a wound rotor. Okay. Okay. This is just a review of previous sessions gone. Okay, so I don't need to do anything much on this. This is just for you to recap on and make sure that you have covered these items for yourself. You have to have covered these items for it to be effective and for your learning to be effective as a training electrician. Okay, there is no excuses, there's no shortcuts, there's no quick fix. Okay, squirrel cage induction motor, and here we have our squirrel cage induction motor. There are two general types of three-phase motors: wound motors and squirrel cage. Okay, here again I've covered this previously in another session. Okay, so I'm not going to spend too long going over this again with you. Okay, so again, just read the information, and I've given a wide explanation on this previously. So here we're recapping on what we did earlier. This diagram shows a simplified three-phase squirrel cage AC induction motor. Okay, squirrel cage induction motor. The rotor of this type of machine contains thick bars of aluminium, okay, shorted at the end by aluminium rings. The rotor also has a laminated steel core which concentrates the magnetic field. Okay. Now you've seen this before, okay, previously in another session, so I'm not going to take this on too long. Recap yourselves overall. Okay, let's just make sure it's in view, okay, and it's in full screen. Okay. Again, here's your wound motor. Okay, and you've seen something like this before. So again, I'm not going to take too long on this. Okay. Now this diagram you should draw out. The wound rotor induction motor showing rotor resistance starter. Now this is a rotor resistance starter. It has external starter which brings in variable resistance. So you will put it into the start position first, and the motor will begin to wind up slowly, and it will begin to wind slowly and gather up speed. And as it begins to reach a certain speed, you'll click switch to run, and the motor will then continue to run from that position. Okay. And this is done by certain contactors allowing the position and holding position. And here is where you will look at A, held in the run position, B, held closed in the start position. Okay. And this is your handle. Okay. Now the handle actually isn't in your diagram, it's external, so all this is in a case. It's in a kind of metal casing, and all the mechanism is inside that casing. Okay. Let's just go make sure we can try and get this up closely to you. Okay. Okay, let me just make sure we can get this diagram for you to see fully, okay, in detail. Now again, you need to be drawing this out, okay, and you should be drawing it out in full, okay. Okay, just make sure you can see it, and just pan back, make sure we get it in full view. Okay. Okay, right. Now, again, stator windings, rotor windings, okay, and those are your brushes here, motor shaft, slip rings, okay. And again, this is your wound rotor induction motor showing rotor resistance starter, okay. Now, advantages of wound rotor motors. Wound rotor motors are useful for startup of heavy loads, variable speed drives, frequency converter. The wound rotor motor is driven by a separate squirrel cage induction motor and acts as a three-phase generator. Okay. Okay. And here we are, frequency converter, three-phase main supply, squirrel cage rotor, wound rotor induction motor. This bit here is what what's called a damper. It minimizes vibration between this and this, okay? Now, there's nothing much to say here other than to advise you to do some additional research in regards to frequency converter. Okay, but what this does, this drives this induction motor in the opposite direction, which is then generated an output here at a given frequency. Okay, so I'm not going to go into that at this point because that is for you to read up on and to begin to draw the diagrams yourselves and look at the formulas that's been applied in regards to frequency conversion. Okay. Okay, thank you. That will be for today. I hope you found it useful. Okay, so take care for now. Bye bye.